Alright, so how would you solve this integral? You have the integral of cos cubed of x divided by 1 minus sine of x dx. So obviously, since you have cos cubed of x, this looks pretty complicated, but trust me, it's not as complicated as it looked. So what you have to do is you have to use trigonomic identities and this, some algebraic identities that you should know to kind of change this expression. And then after it's going to be changed and it's going to be simplified, then you'll be able to use u-substitution. So here's how you would do that. First, what I do is, well, usually when you have 1 minus sine of x, or you have 1 plus sine of x, it's usually a good idea to multiply those by its conjugate, meaning that, for example, if you had 1 minus sine of x, you could multiply that by 1 plus sine of x in order to get 1 minus sine squared of x, which is equal to cos squared of x. And over here, you could multiply this by 1 minus sine of x, and so then you would get, again, the same thing, and that would, be equal to cos squared of x. So the conjugate is essentially where you have, for example, a minus b, and then you multiply that by a term that is similar, but you just change the sign in the middle. This becomes a squared minus b squared, the difference between two squares. So that's essentially the idea behind what I want to do here. So what I'm going to do is I'm going to actually multiply up and down, because you have to multiply. If you multiply, then you also have to divide. So what I'm going to do is I'm going to essentially, I have 1 minus sine of x here, and so I can essentially multiply this by 1 plus sine of x. But since I'm essentially dividing my expression by 1 plus sine of x, I also have to multiply it by that same thing. There you go. So in order for the value of the function to not change, because if I didn't do like the multiplication up there as well in the numerator, then the expression would just change completely. So you need to make sure that you don't forget to multiply up and down or divide or whatever to make sure that your expression overall doesn't change. Now this is going to become the integral of cos cubed of x times 1 plus sine of x, and this is going to be divided by 1 minus sine squared of x dx. Now this is going to become the integral of cos cubed of x times 1 plus sine of x divided by cos squared of x dx. Why is that? Well, 1 minus sine squared of x is equal to cos squared of x because 1 is equal to sine squared of x plus cos squared of x. So you can see how these two are related. And so now you can see that you can actually basically simplify this integral a lot. You can cancel out this over here with 2 of these, and this becomes 1. And so now this becomes the integral of cos of x times 1 plus sine of x, and this becomes a very, very simple u-substitution problem. I'll let u be equal to what seems the most obvious to me, 1 plus sine of x, and then du becomes cos of x dx. Or in other words, you could have said du over dx is going to be equal to cos of x, but you can also say that du is equal to cos of x dx, and you can find that exact expression over here. You have du and cos of x dx. Well, that's exactly this over here, and as you can see, this is going to be u. So there you go. So this expression becomes a lot simpler. You get u for this over here, and then cos of x dx, those become du. And there you go. So this is very simple to solve. This is 1/2 u squared plus c. And now you just have to simplify. You have to, replug your u inside, which was 1 plus sine of x, and that's squared plus c. And there you go. That's the answer to your problem.